We've been looking at topic 1, engineering history, and the guiding question for that is how has the history of engineering informed contemporary engineering practices? Now, today we're lucky enough to have an interview with an expert engineer from the US. He's actually Australian born, grew up in Brisbane, and attended an independent school in Brisbane with me, not unlike the school that you're going to now. He's got a really interesting story to tell that he touches on a few different aspects of his career in the interview, and hopefully you'll find it really interesting. He was a little bit shy about a couple of little achievements along the way. He's actually got some remarkable achievements in his career with race wins. In 2018, I think it was, he won the NASCAR championship with his NASCAR team and was invited to the White House, met President Trump, and all the trimmings that go along with that. He's also had race wins with the V8 supercars, as well as some pretty successful races in the Indy racing as well. So for a kid that was growing up in Brisbane to where he's at now, he's got some really interesting stuff to tell. Hope you enjoy the interview.
Sunshine overhead, temperatures in the 80s, fans pouring into the Homestead Miami Speedway as everyone awaits a new series champion. Could very well be the last pit stop of the year.
Here we come. 3, 2, 1.
Number 1, Martin Truex Jr., followed out by Kevin Harvick.
Good. 8 over. Hit your marks just like we've done all year.
Truex Jr. riding for his life and riding for a championship.
Under the checkered flag.
Yeah! You are the champion, baby!
Welcome, Pete. Thanks for joining us today. What we're looking for your advice on today is sort of looking at the pathways that a young person can take to get into the engineering field, and we'd be really interested to hear about the pathway that you've taken from being a student at a school in Brisbane through to where you're at now.
Yeah, no worries. So, yeah, I'm in grade 11. I was doing a lot of science-based subjects, so physics, chemistry, maths B, and then I did engineering technology as well, and that's kind of what was the basis of what I needed to do to get into a mechanical engineering course at UQ. So then went to UQ. I did mechanical and space engineering. The first year of that, a lot of that is pretty broad. Like you cover a lot of stuff that's in civil, say mechanical, electrical, mining, and then you specialize as you go through. So I went down the mechanical path, and at the time I wasn't sure if I wanted to go into racing or into like aerospace, and I ended up joining for a student race car project, which a number of the universities in Queensland have, and all around the world. It's called Formula SAE. So I joined up with that team, and that sort of led me onto the path of, the racing side of things. So, during your time at university, to get your degree, to finalize your degree, you have to go and do some work experience. And so I did my work experience with one of the V8 supercar teams. And so, over the break between semesters, I spent time with them down in Melbourne, went to the races with them, and then for my 4th year undergraduate thesis, I did it as an industry-based thesis with those guys, I just worked on some small projects for them while attending the races as one of their junior engineers, doing, you know, simpler tasks for them that they needed, like data analysis, like crunching through data, that sort of thing. So then that led to a job in V8 supercars. So I worked for Jason Bright's team for a couple of years. I worked for Rick and Todd Kelly for a few years. And then at the end of 2011, I got offered a job in the US to come and work with an IndyCar team. So I moved across to the US and worked for Michael Andretti's team for a few years. And then from there, I ended up joining up with a NASCAR team for a few years. And then I'm now back working with an IndyCar team.
Okay, great. Can you tell us about some of the successes that you've had in the V8s and Indy and NASCAR, and maybe some of the challenges that you faced along the way as well?
Yeah, I've been in various teams. I've been in teams that have got big budgets. I've been in teams that have got really small budgets, and typically in racing, like the big budget teams typically win. But yeah, in V8 supercars, I was part of a couple of wins there with Rick and Todd Kelly. And the challenges that we faced there was, at the time, you had to design and manufacture most of the car yourself. There were strict limitations on the rules, but that series, a lot of the engineers have kind of multiple roles. So during the week, I was a design engineer, so I would be working on CAD, working with fabricators, measuring the car, designing new parts, getting them manufactured, and then, on a Thursday, we'd run to the airport, get on a plane, go to the racetrack, and then at the racetrack, I was, working with drivers and other engineers, and we were looking at a lot of data, and then trying to figure out how to make the car go faster with what we had. So, that was pretty busy, and you sort of had to like swap your roles at different times during the week. And then, coming into moving over to the US, the IndyCar Series is a little bit different. You don't, it's more of a spec series, so the car is, basically the same between all the competitors. So you're not designing parts, all day, every day. You tend to do a lot more focus on data analysis and the race engineering side of things. So, performance of the vehicle, like there's a lot more sensors on the cars, a lot more aerodynamic work. I mean, in the US, we've got access to wind tunnels, shaker rigs, whereas those things don't really exist in Australia. There's no full-scale wind tunnel that you can take a race car to. Only Holden and Ford had 4-post shaker rigs, whereas over here, most NASCAR teams have their own shaker rig, and it's a 7 or an 8-post. So you've got
What is a shaker rig?
Shaker rig. It's basically, you can put a car onto this rig. So under all 4 of the tires, you have actuators, and then for a 7 or an 8-post, you then have your actuators and aero actuators. So basically, you can mimic the road input into the vehicle. So you'll have a car there, and it'll just be bouncing around on all these 7 or 8 posts, and it's to try to mimic like what the car's doing on track. And what you use it for is to tune your suspension and your dampers. So you're trying to, in a nutshell, what you're trying to do is reduce vertical load at the wheel, where the wheel contacts the road, because effectively that's what grip is, mechanical grip. If you can reduce those oscillations, you'll end up having better ride, more grip, and your car will go faster through the corner, and that's ultimately the goal. So yeah, really, you don't have a lot of access to that that sort of technology in Australia. So yeah, in Indycar Series, I was at Andretti Autosport. I was there for the years that Ryan Hunter Ray won the championship in 2012. He won the Indy 500 in 2014. So at the time, we were running 4 or 5 cars, and so there was a big group of engineers, and everyone was split on different cars. But that was a period of success for the team. And then when I moved to NASCAR, we sort of started out as a team that were kind of a midfield running team. And again, so in NASCAR, you do design a lot of your own components. But you also have a team of engineers just working on performance. So I didn't do any design work on the NASCAR side. We had design engineers that worked on that, and so we had 4 really high-level engineers that worked just on vehicle performance, and so we went from being like a midfield running team. We had 1 win in our first year, and then 4 the next year, 8 the next year. We won the championship, and then had some more wins the next year, and then the team owner decided he didn't want to go racing anymore, so he shut that team down. While we were kind of on a roll with our success, but that's just the way it is with race teams sometimes. And yeah, now back in IndyCar. So again, I don't really do a whole lot of design work. I'm now the lead engineer on this car, so all my time is devoted to performance engineering of the car, organization with the driver, the mechanics, the team manager, our engine partner, that sort of thing. So we're kind of a midfield running team right now, knocking on the door of top 6s, but we're not a consistent, pointy end of the field running team right now, but that's what we're trying to achieve.
Championship yet?
Sorry?
You're not really fighting for the championship yet?
No, we're not yet. And we're right now. We've had some podiums. I've been with this team now. I'm going into my 3rd season, and we've had some podiums, but it's not like we're regularly in the top 3 in all the sessions. So we're really kind of fighting tooth and nail to try and get up into that top 5, which is really hard to do. It's a very competitive series, but we're not quite there yet, but we're definitely chipping away in that direction.
So can you describe for us what sort of roles and responsibilities you've had throughout your career, and how I'm guessing you've sort of stepped your way along, and then what sort of position you're in now?
Yep. So when I first started working with a race team, you kind of typically start out as like a junior designer or a data engineer. So data analysis, design work, like kind of lower level things. In supercars, I was designing oil tanks, brackets, mounts, that sort of thing. And then you kind of, as you get more experience, you end up doing more and more. So eventually I ended up working on the roll cage and the body work. And a lot of that is, surface work, so it's a lot harder to work with. But, and you need to do finite element analysis if it's like a structural part to try and minimize the weight, maximize the strength, that sort of thing. But again, in V8 supercars, you have your multiple roles. So if you're a data engineer, you typically become an electrician as well. So I did a lot of electrical work on the cars. I could design and build electrical looms and harnesses, maintenance of all the sensors, that sort of thing. You typically would also work on the shock absorbers. We call them the dampers. So you would, in any given week, you would be servicing the electrical side of the car. You would be building and rebuilding new shock absorbers, doing some design work, and doing some performance work. So then, if you're in that kind of junior position, you sort of do a little bit of everything, and then
Become
typically,
the jack of all trades.
yeah, a little bit, and then from there, you kind of in racing, you kind of tend to go one of two paths. You tend to go the design route, where you kind of become a more senior designer, or you become a race engineer. So I kind of took the race engineering path, and like I said, it's it's less design work. So I haven't actually done very much CAD the last few years at all. But I do a lot of performance work. So I look at a lot of graphs and numbers. I crunch a lot of numbers. I do a lot of simulation work. So I run single lap simulations, and then I also run big batches where I send an experiment up into onto a cloud platform and run hundreds of thousands of laps, and then pull all that data down and then start sifting through it all, trying to find the trends that we're looking for that will give us more speed. So um, that's where I'm at now, is on the race engineering side. And right now, like I said, I'm the lead engineer on the 20 car, so my responsibility is ultimately for the car's performance. So in a nutshell, my job is to make the car fast, and so we do that by doing analysis before we get to the racetrack. Looking at things that have gone well for us at certain circuits and why they've gone well, and then running simulations on what we think is going to be fast at the next track, running those simulations, pulling down the data, looking at it, deciding what uh, what is feasible, because sometimes a simulation will tell you this is a great setup, put this on the car, but your your years of experience have to then tell you that it might look fast on paper, but it's probably not a drivable car, say. So you might put that setup onto a car, and the driver will not like it at all. He'll say, I can't drive that. It's not giving me the feedback I need. So you then need to dial it back. So that's where, when you get to the position I'm in, you get to call on a little bit of the science that we try to work to, but then you also have to bring in a little bit of your years of experience and marry them together to try and produce what is the fastest possible car you can. And so in that position, like I said, I work with our mechanics, so I lead them on what we want to do, how we want to build the car back at the workshop. So I'll give them a build sheet. It'll tell them, all the basic parameters of the car, like what suspension geometry we want to run, what damping package we're going to start with, where we need all the weight around the car to get the right weight distribution, that sort of thing. Then, I'll come up with a run plan for, an event. So say we go to a racetrack, you typically will go out for a practice session, and what that means is you'll go out and you might do 5 laps. You'll come into the pits, and then the driver will tell you that I don't like this car. It's got too much understeer. So when I turn the wheel, the car wants to go straight, and I want it to turn more. So I'll direct the mechanics and say, okay, well we're gonna change the rear spring. So we'll we have 5 or 6 mechanics on the car, and I'll say, okay, we'll increase the rear spring rate by this much, and then we'll change the ride height by this much, and so they'll go and put that on the car. It'll take 2 or 3 minutes. They can do it really quickly, and then we'll go back out and do 3 or 4 more laps, and the driver will come in and say, yeah, that was better, and we'll go faster, and that's how we then progress through a practice session. So at that stage, yeah, I lead the mechanics on what we want to change. I work with the other engineers on our car. So we have a performance engineer who looks mainly just at the data, making sure everything is correct, like we're hitting our ride height targets, our dampers, performance of our dampers and shocks are all good. So he's kind of like the junior engineer. And then we also have a data engineer who looks after the health of the car. So all the fundamentals and the basics, like is everything operating correctly? Are all the systems working? So they're a data engineer, or you can call them a systems engineer. So is the car functioning as it should? And then we have an engine engineer who looks purely at the engine parameters. So, are we in the right cooling range? Do we need to adjust the boost level? Do we need to run a different throttle map? Do we need to run a different kind of traction map? So we've got guys, different guys looking at all different parts of the data, and then I kind of have to look at the whole package and take the input from the performance engineer, the system engineer, the engine engineer, and then kind of bring it all together and say, okay, are we doing the right thing? And then say to the mechanics, okay, we need to do this, and hopefully this will make us faster.
Okay, great.
Clear by corner? Oh, you pull it. Hell yeah, you the man. No, we did, but it's freaking terrible. This is frustrating. But I'm there today.
So I'm interested to hear your thoughts on so engineering as an industry, and I suppose you're obviously coming from the bias of mechanical engineering in the racing industry, but what sort of current and future opportunities do you think exist, and where do you think the industry is going in terms of the skills that young people will need, how to make them more employable, and the day-to-day sorts of tasks and routines that you'd be doing?
Yeah, that's a good question. I think that there's always going to be a need for engineers in society. So, having a good, thorough understanding of the maths and science behind certain principles is always important. That's something you can't go past if you're looking at somebody to employ them as an engineer. The thing I definitely have noticed, and we need more of, is computer science ability. So I know typically, when you go through high school, it's probably even in primary school now too, that you start doing programming, like computer programming. I did Visual Basic, Python, and MATLAB, and those are all relevant to what you'll need going into an engineering position typically. So I would say in my field, MATLAB and Python is something we use a lot of. I do a lot of Visual Basic work myself, but I would say that, and then going even further than that, definitely like computer science married with anything civil or mechanical is where I think things are going to need to go. Like if I was to look at hiring somebody right now, I would definitely want somebody with a good core knowledge of engineering principles. But the second thing I would look for would be ability to kind of marry up the computer science side of it with the kind of raw mechanical or civil engineering side. So, like I said, a lot of the work we do is simulation work, and I know, a lot of the auto companies right now, Tesla, GM, Ford, a lot of the people that they're looking for is to work on autonomous vehicles. And so that's where you've got to marry in the mechanical engineering side with the computer science side. You need to be able to simulate what a car's going to do, an autonomous vehicle. You're going to have to then make that, computerized system work with the mechanical parts of the car. So I think, to me, that's the direction that things are going, and I think it's happening across like a broad range of industries. Like you're going to see, even in like a purely manufacturing world, people are going to need to be able to, design a part, then, work on the NC code so that you can send it straight to a machine and it manufactures it. So that's where I think the industry is going in general.
I get the impression from speaking to you and other engineers that I'm familiar with that sort of on a day-to-day function, whilst it's important to have the base level of knowledge that you've learnt, whether it be at high school and university, etc., and obviously the experiences that you collect along the way, you don't typically do a lot of crunching of numbers, with pen and paper sort of thing. A lot of that is very much controlled by calculators and software now. Is that sort of correct? And then, um, there's also a lot of people management involved in engineering. Is that sort of fair to say?
Yes, yeah, both of those things are pretty accurate. I mean, I can't say I sit down and write equations of motion every day. I do that very rarely. I do calculus quite a bit, but it's usually pretty simple stuff. Like we measure the position of our shock absorbers with a linear sensor, and we're not really interested in the linear position of the damper. We're interested in the velocity, so the speed, which is the first differential of position. So, I daily use our data analysis tool, which automatically converts that position into a velocity. So you need to know, how all these things are used. Like if you need to find the area under a graph, you need to know, how to do the integral. If you need to, convert position into velocity into acceleration, you need to know how to do the differential. But I can't say that I sit there and manually work it out on pen and paper. I either throw it into Excel typically, or a program I use like Pi Toolbox or Motec, interpreter. It will do the calculation for you. You just need to know what you need. You need to know how to solve the problem rather than actually do all the manual calculations yourself. So yes, as long as you can, I think the importance of engineering and learning all the fundamentals in school is that it teaches you how to approach a problem rather than having to sit down and manually do it every time. And then your second point, I mean, I don't know the exact stat, but it's something like 90% of engineering students end up as just managers. And at that point, I think those people probably very rarely do any calculations. But again, it's knowing what is needed to approach certain problems, and having experience in the field to say, or the experience to say, okay, if somebody, suggests some, method of their thoughts on how to solve the problem, you kind of need to have the experience to say, well, that's a good idea, but I don't think this is going to work because, that load is not going to work in that way, or, you can't solve it that way. It needs, this and this to help it. So I think in general, you're not gonna be doing, pure maths every day. You just need to know the basics of it and where and when you can apply it.
Okay, great. Well, thank you so much for your time today, and we'll leave it there. I'm sure all of the kids got a lot of it out of that. So, thank you so much,
All
and
right.
we'll chat again soon.
All right. Talk soon.
Thanks.
Bye.
And there we have it, from Brisbane to the big leagues in the US. I hope you found that interesting. One of the things that I found really interesting about that was some of the things that Pete touched on at the end of the conversation there. I think they tie in, some of the things that he said tie in really, really nicely with those 21st century skills that all of your senior subjects are trying to teach you. We've got critical thinking, creative thinking, communication, collaboration and teamwork, personal and social skills, and ICT skills. One of the things that Pete really emphasized was that it's those sorts of skills that sometimes people consider sort of more soft skills that are really, really crucial in an engineer's toolkit. Whilst you have to have that base level of knowledge, it's a lot of those skills that you'll find that you'll be using each day.